Why do I care so much about buildings? It's a good question. I think I've always been into looking at how things work. If something doesn't work, then why doesn't it work? But usually with a view to kind of, if I find something doesn't work, how do we get it to work? I think buildings, we can go around pretty much any building that you go into and you can find something that can be improved. So what happens in the building is really important. And you go in a bad building and you can feel it. You know, we came in here today. First thing I did was complain. It's very warm in here, isn't it? And it affects how people are. And, you know, and we hear the horror stories around mold and health problems and things like that. And that's the extreme end of it, unfortunately, getting more extreme and more common, unfortunately. But anything that you do in a building is affected by the building itself. So I see buildings as a place where we spend a lot of our time, and there's always room for improvement in buildings, right from the old buildings like we're in now to new homes that are being built. So yeah, I go with a meal with the missus, and the first thing I'm doing is looking at how a building can be improved. It's damp on the ceiling, you know, that fire exits, things like that. It's kind of something that you develop and you never switch off, and it is fault finding ultimately, but fault finding is useless unless you can kind of fix it. And I think that's what I like to do. Find something wrong, fix it.
So at the moment you're a professor at Salford University,
yeah.
But what do you actually do?
So I'm my title is Professor of the Energy Performance of Buildings. Okay, so that's what my chair is. What do? I don't teach a lot. I teach a small amount on the building surveying course and the masters that we have in sustainable buildings, which I enjoy. My 90% of my time is researching how buildings perform. So the history of kind of what we do, if you like, which will tell us kind of what I do day to day. But when I started 12, 13 years ago, we had a project that opened on the day I started, which was called Energy House. So Energy House is a 1900s Victorian terrace in an environmental chamber. So a full-size building, 1.5. So it's got number 1 and number 3, exactly as you'd find out in the field. Built using reclaimed bricks, recycled materials, and we've validated that it performs the same as a house outside.
And so this house is built inside of a larger.
Absolutely. So it's in a large environmental chamber, but the bricks are 100 years old. Well, more now. The materials that we use to construct it are all consummate of the materials that would be used at that time. So it behaves the same as that building. And the thing that makes it unique and globally unique is that we can alter the temperature and the weather and the climate, if you like, in that chamber. So we can go down to -12, up to +30, wind, rain, snow, solar radiation. And we can put all those things on in any quantity we like. So you're talking really the Northern European climate we can recreate in there, certainly the UK climate. And the whole point of that building was to examine retrofit in the UK at the time. And we've examined retrofit. We've pretty much looked at everything that you could put on, change, alter, install, or take off a building. So right the way through to full deep retrofits, you know, with walls, floors, ceilings, windows, doors, heat pumps, you name it, the full package of work, right the way through to looking at curtains and carpets and the smaller but more cost-effective energy-saving measures. It's a mix of funding between government funding, academic funding, funded through the university, and commercial. So about 60-odd% of our work is commercially funded through industry. So whether that's boiler manufacturers, energy suppliers, building product manufacturers, you know, there's a really good mix of people. And right down to one-man bands, literally out of garages and sheds through to the multinational, multi-billion-pound companies. And I think it's a really healthy mix.
So can you give me an example then of things that you've discovered from the house project?
Yeah, I mean, discovery is a strong word. You know, we didn't find graphene. You know, what we do find a lot is things that do work and things that don't work, or don't work as well as perhaps they could or should.
Okay.
So, but part of the fun, I think it's fun, is not also finding something that works and confirming that it works. It's nice to find things that work slightly better because for the environment that kind of helps, and it's pleasing. It's nice to see someone happy with their test results. But it's also good for us to find things that don't work so that they don't get installed in buildings, and they don't get installed at a very high cost and make very low savings.
So give me an example of that then. What historically do people believe, or did they believe, that would work really well in a retrofit? Through the research that you've done, it's actually negligible.
A paper we published, I think 7 or 8 years ago. I guess you can put a link to this in the description. I looked at thermal paints. Okay, so coatings that you put onto a wall and ceiling that claim to make some pretty significant savings. So some of them were advertised with savings if you paint all your walls and ceilings, with savings up to 35% of your energy would be, heating energy would be reduced. An incredible amount of savings. We found that when you compare them even to things like vinyl paper, wallpaper, EPS, very thin EPS sheet like we used to put on in the 70s to stop condensation, they're nowhere near even that. The savings, we found paybacks up to 200 years because the sheer amount of paint you need to put on a wall to make the saving, and the simple fact that they didn't save hardly anything from a U value on a solid wall was quite stark. So, but being sold in quite considerable numbers. Now, thermal paints do have some use, and that's to lift the surface temperature of the wall. So in condensation cases, they can often help. They provide this kind of very thin layer of insulation, which can just bring that wall away from being a condensation risk. But to say they're going to save you a great deal of heating energy, well, your listeners can read the paper. Yeah, I'm not. So things like that, I'm a big believer in proving things don't work if it can help society find out that it doesn't work as well.
What have you found works really well? What stands up well? And
so again, there's been no graphene moment. There's no eureka moment. We found a lot of things that work as they should, and to me that's a good finding, because you're heavily involved in the design of buildings, Darren. And when as a designer and an evaluator of a design, when you've got some surety and confidence that what you put in is going to work, that's good, and that to me is a good finding. There's been some things that have surprised me in a nice way. So there's a product called Thermosil, which is by a local innovator. And Thermosil is a window board that you put across. You take off your old window board, a windowsill, some people call window ledge, some people call it, and then you put on this sill. And as we design buildings, generally in the UK, we have a radiator underneath the window, which is fine. It's convective flow. That's kind of how it should be. What Thermosil does is channel the air, the warm air rising in front of the window, lifts the surface temperature of the window, creates the same effect as a mini air curtain. So when, for your listeners, you walk into Marks and Spencer's and you get the air curtain effect, and it stops the heat or the cool leaving the building. So that's the effect that they claim to have. And it's counterintuitive if you think about it, because you're funneling heat next to a cold surface. So I had some thoughts, but as a scientist, you should put them to one side and just do the experiment. And my instinct was it wasn't going to work. It did work. And the savings aren't, colossal. And again, there's a paper just gone out on this topic, and if you Google it, you'll find our findings. But over a U value, it's a couple percent. Okay, and it changes at different points in the window and stuff as well. But again, when you look at things like condensation, that can have quite a marked effect. And if you can turn a house that's got condensation problems on single glazing into something that doesn't, then that's a win as far as I'm concerned. But it was counterintuitive, and I explained it with physicists that are far better than me. I'm a building physicist. I'm not a physicist, and I've explained it to engineers who are far better than me. And it's counterintuitive, but you've got to do the test, and we found it worked, and we've been working with Thermosil now for probably about 7 or 8 years with a view to providing data to get them through SAP and things like this.